All right, now, you guys see that we have, in this case, in this example, we have 2 to the power of 3 times 2 to the power of 2, okay? What is your base here for the first one? So 2 to the power of 3, what is your base? 2. 2 is your base, what's your exponent? 3. And then for the second one, what's your base? 2. What's your exponent? 2. So do you guys agree with me that both of them have the same base? They both have the base of 2, right? So if I want to actually expand this is 2 times 2 times 2. That's for the first one, right? And then I have times, well, that's this multiplication. And I have 2 times 2. Do you guys agree with this? That if I expand this, this is how it's going to look like? Yeah? So the green is because 2 to the power of 3, so that's 2 times 2 times 2. The blue one is the multiplication, and I have 2 times 2. Are we okay with that? What was your question?
Why do you do it like that?
I'm just expanding. I just want to show you something. Okay? Doesn't make sense as an expanded form.
Expanded form, yeah.
Okay. Now, how many 2's do I have multiplied together?
2 sets.
But how many? So I have 2 times 2 times 2 times 2 times 2. You guys agree with that? You don't see that they're all 2's multiplied together?
Yeah.
Yeah. Right? So how many 2's do I have multiplied together here? 1, 2, 3, 4, 5. So can I write this as 2 to the power of 5?
Can you?
Yes, I
sure
can.
You can. Can't you?
I can.
I swear you can. Because that's what I was thinking of when I stopped you and I was showing you.
Yes, I can.
There's a better way to just write it off like that.
Yeah. What? You're not getting that answer?
No, I got a different answer. I got 24, and because then doesn't that become 6 times 4?
2 times 2 times 2, that's 8.
Oh. That's why.
Yeah. So does that make sense? That is 2 to the power of 5. Now I want you to look back here and tell me, how can I get 2 to the power of 5 if I have this?
Well, it tells you
If you combine them,
if you combine them.
If you combine them, what do you do?
add the exponents.
With the same base, you add the exponents. Okay? So if you look at this, I keep the base is the same. My base is 2, I'm going to keep it as 2. If I add 3 plus 2, what does that give me?
5.
5. Okay? So now, without me writing in an expanded form, if I have anything, so if I have, let's say, 4 to the power of 5 times 4 to the power of 7, right? All what I have to do is I keep my base and I add my exponent. So that gives me 4 to the power of 12. Okay? As long as I have the same base and I'm multiplying, right? I can add my exponent. Do you guys get this?
Sometimes.
Okay, so let's do a couple of examples. So I have x to the power of 3 times x, this is a multiplication, times x to the power of 4. Do I have the same base?
Yeah.
What's my base?
The X.
X. And then what is happening between the two terms? What am I doing?
It's just
I'm multiplying. Okay? So if I'm multiplying, I'm going to keep my base the same. And what do I do with my exponent? Add them. So it's 3 plus 4. So that's going to give me x to the power of 7. you're multiplying, the rule says you have to be multiplying, right? Then you add your exponent. Okay? Let's try one more example. 7 to the power of 10 times 7 to the power of 3.
So seven.
Plus, no, 10 plus. So the base stays the same.
So the base stays the same, which is 7.
But then
And then what do I do with my exponent?
You add them.
So it's 10 plus 3,
13.
which is 7 to the power of 13.
Oh shit. So
The important part is that I have to have the same base. If I don't have the same base, I can't do this. Okay? Because it doesn't make sense. It doesn't work. Remember that I showed you that the reason that worked is because the 2 is actually the same, right? It's 2 times 2 times 2 times 2 times 2. That's the only reason this worked. It's because it's a 2. That it's the same number that's being multiplied. Okay? A to the power of 3 times B to the power of 4.
can't do that, miss.
Can't do that?
You're not the same base.
Can't do that? No.
Can you-
So this stays the same. There's nothing I can do with this. Nothing I can do to simplify.
That's something I would do.
Good job. And that's because it doesn't have the same base. Okay?
Just like
Because they don't have the same base.
That makes sense.
Good. Okay. Now, let's look at what happens if I'm dividing. So we looked at what happens if I'm multiplying. So if I'm multiplying, I add my exponent. Okay? If I'm dividing and I have the same base, I'm going to subtract the exponent. That's what the rule says. But let's look at why is that true. So I have 2 to the power of 4 divided by 2 to the power of 2. Okay? So if I'm gonna write this, I'm gonna rewrite this like this: 2 to the power of 4 divided by 2 to the power of 2. You guys agree that this and the division sign, they mean the same thing, right? We talked about this before. We said if you write it as a division like this or as a fraction, it means the same. Expand the top for me. What would I write if I want to expand the top?
2 times 2 times 2.
Yeah? 2 multiplied by itself 4 times? Okay, how about the bottom?
2 times 2.
Yeah. Now, if I want to simplify, because I'm dividing, basically I can get rid of stuff. If I'm multiplying here, so you see how it's all multiplication, I can actually go like this, right? Because they simplify. If I have 2 chocolate bars and there's 2 of you, I can distribute them. I can simplify. Okay? So, boom, boom.
2 times.
So what do I have left? 2 on the top. You see that? I only have 2 times 2 on the top. What's 2 times 2 if I want to write it as an exponent?
2 to the power of
I'm going to try with a letter because it might make more sense with a letter. Okay? So let's look at this. If I have x, I don't like x's. A 3 over, I should do something else. Let's do A5 over A2. Okay? Let's try. So if I want to expand the top, what happens?
8 times 8 times 8 times 8.
We're good with that?
Yeah.
Everyone? Okay. The bottom.
A 2
A times
8 times
A. Okay? Now, because you're dividing, you can actually simplify. if you have the same thing. So I can actually divide A by A, I can simplify them. A by A, I can simplify them. What's A divided by A? What's 10 divided by 10? What's 5 divided by 5? 1. What's 7 divided by 7? 1. Anything divided by itself is 1. So that's why a letter divided by itself is gone. It's 1, right? So I can eliminate it, right? So A divided by A is 1. I can eliminate that. That's why I can eliminate them, okay? So how many A's do I have left on the top? 3, and they're all multiplied together, right? So that means that's the same thing as writing A to the power of 3. Yes? I feel like half of the class is agreeing with me. The other half, no.
This is confusing to me. I just did minus.
Mm-hmm.
Like writing it out like this, like completely, I'm like, whoa.
Okay.
When I just write it like 4 take away 2 or 5 take away 2, then I get
Okay.
3.
So
and
you
then-
understand, you know the rule, but you don't know why this is happening. I'm explaining why this is happening. I'm okay if you understand the rule, if you know the rule and then you do the rule, but this is to understand why the rule works. Okay? So, if you want to understand why the rule works, this is why.
No, I get it.
Okay? So, if I do 5 minus 2, what do I get? 3. And this is how they got the rule. This is why the rule works. So basically what they do is they take the base, it's the same base. So they take the base and they subtract the exponent. So that is A to the power of 3.
Yeah.
Okay?
Like,
That is,
so much fun.
exactly. So this is basically the formula
Yeah.
to get to your answer. This is why the answer works. This is why we're getting this. Okay? I'm not going to ask you to show me why this formula works, but I'm going to ask you to show me what the answer is. What is your answer? So if I have A5 over A2, what is your answer? It's A to the power of 3. Okay? So let's look at another example here. If I have 7 to the power of 4 over 7. What's the power on that 7 at the bottom? That's the power of 1. Right here, it has an invisible 1 on top of it. So what do I do?
So would you get to put the base on before this 4 seconds?
So I'm not going to expand, I'm just going to use the formula. Okay? I keep the base the same. What do I do with my exponent? Subtract them, so it's 4 minus 1. What's 4 minus 1?
7 to the power
Of 3. Okay?
So it would be subtraction.
So I take the exponent and I subtract.
Subtract it? Okay. So if it has no number, just
It's a power of 1.
power of 1.
Power
So
of
if
1.
it doesn't have any exponents at the bottom, it's always 1.
If it doesn't have any exponents, no matter what it is, so even if I write for you A, right? If it doesn't have any exponent, that's actually exponent of 1.
A hidden one.
Yeah. We don't write it.
It's hidden.
You have to remember that.
Remember that it's hidden.
Okay?
It's like a thing, how do you store it? You know, it's those hidden treasures. And you have to make sure you just remember it there. So, I don't know. So, that would be the subtraction.
Mm-hmm. So I'm going to have to leave my base. What's my base?
6.
B.
Oh, I thought it was a 6.
And then what do I do with my exponent?
Subtract.
Subtract. So 10 minus 5. So that gives me B to the power of 5.
Wow.
Okay?
Wow.
What if one base is held and one is moved? They don't count the same?
No.
I'm a doctor now.
Okay, can I go back to the lesson?
Yes, miss. I forgot coming back.
Okay, here's another rule to you guys. So I'm gonna write the rules here, okay? So the rule, if they're multiplied, then I add my exponent. So I'm just writing the rules here. If they're divided, as long as I have the same base, I subtract the exponent. It was working like 2 minutes ago. I don't know now. I haven't changed. I'll check and I'll let you know. Thanks. Okay. How about on the calculator, try something for me. What? You have a question?
Yeah, miss,
What?
like, you see how?
Okay. Now, on the calculator, I want you to try something for me. Do 2 to the power of 0.
1.
Do 2xy 0. What do you guys get?
One.
You got 1.
One.
Everyone? Okay, try 99 to the power of 0.
1.
This one.
Yep. Equals.
So anything by zero is just one.
Anything to the power of 0 is 1.
But is it the base? No?
It's the answer.
It's the answer.
So even if you do 1,000 to the power of 0,
It should be
your answer is going to be 1.
1.
Oh.
But the power 0. I'm still. What
Uh,
the power? What does the 0 do?
Now, if I'm going to teach you why is that, you're going to get lost.
Yeah. Well, please.
No, we're good.
Okay, if you want to pay attention to why that is, just follow me. Okay? If you don't want to pay attention to this, you don't have to.
Taking a nap.
I don't know what nap, but let's look at this. If I have a squared over a squared, what do I do when I have same base and divide it together? What do I do? What do I do with the exponent? Subtract. So let's subtract the exponent. What's 2 minus 2?
0.
So it's a to the power of 0, yeah? Okay. Now let's take the same question and let's expand for a second. Okay? If I want to expand this, that's going to be a times a over a times a, yes? Okay. Now my question to you is when I have division and this, I can do this, right? I can simplify. When you divide something by itself, what do you get?
1.
1. When you divide something by itself, you get 1. If I have 10 chocolate bars right now, and then there's 10 of you, right? 10 of us. Okay? Each one of us is going to get 1 chocolate bar. So when you divide something by itself, you're going to get 1. No matter what that something is. It could be a letter, it could be a number. As long as you're dividing it by itself, it's going to give you 1. So technically, my answer for this is 1. But if I follow the exponent rule, it says a to the power of 0. Guess what? These two answers are exactly the same. A to the power of 0 is 1. And that's going to work for every single letter, for every single base, right? As long as my exponent is 0, my answer is going to be 1. Okay? Anything you raise to the power of 0. If you have 1,000 to the power of 0, that's going to be a 1. Even if you have a letter, b to the power of 0, that's going to be a 1. Okay? Anything to the power of 0 is 1. So we've learned 3 rules so far. We've learned something multiplied by something equals, you add the base, you add the exponent, sorry. when you're dividing something by something else, you subtract the exponent, and then to the power of 0 is 1.
Shit, please. This is math, folks.
This is what we know. And find the power of products.
So when finding the power of a product, apply the exponent to each number in the product. Product meaning multiplication.
So, 2 times 3, 3 times 3.
Power. Right? So this is to the power of 2. Okay? So that's the same thing as writing 2 to the power of 2 times 3 to the power of 2. That's exactly the same thing.
That's what I was thinking.
Okay? So basically I'm distributing that power into my numbers.
To your question,
Okay? But technically we're gonna learn a way to do this before we do the exponent. I don't like to do it when you have numbers because you need to technically simplify first, which is, anyway. Same with division, okay? You're gonna do the same thing. So basically that's gonna be 6 to the power of 2 over 3 to the power of 2, okay? So that exponent goes to both numbers if you're multiplying or if you're dividing.